A pleasant afternoon to everyone. We are here standing in front of you to present our research outputs that talks about adaptive pedestrian crossing signal. As a introduction, pedestrian crossing in British English or crosswalk in American English is a part of road painting and is designated for crossroads or pedestrian lanes. Crosswalks are usually outlined to retain pedestrians and together where motorists can see them. For several reasons, the priority should be assigned to pedestrians. However, as highlighted by Luke and Daganso, the inclination to give pedestrians a high priority in crosswalk influences the road traffic capacity considerably. So we are already done with our pedestrian crossing. Now we will proceed to pedestrian signals and traffic lights. So on this paper or this research output, we as the researchers theoretically design an adaptive pedestrian crossing signal system. This pedestrian crossing signal system will mainly make the waiting time of pedestrians lesser and create an easier flow of vehicles as they would not have to stop despite the fact that there are no pedestrians present to cross the road. To give our next about design and discussions, may we call on Mr. Kirkpatrick Martinez for this part.
So for the design of our system, it composes of 3 blocks: the image capturing unit, the control unit, and the display unit. So going further to the image capturing unit, it is the unit responsible for detecting how many pedestrians are waiting at the other end of the pedestrian lane. Simultaneously, it also detects how many vehicles are going or are incoming. So those data are fed into the control unit, which uses the concept of fuzzy logic, which apart from the common Boolean logic, it computes the data based on the degrees of truth, meaning or how true it is. And the output of which will be displayed. So it will determine how much waiting time or how long or how short is the waiting time for the passengers. So for the flow chart, may I call Mr. Brian James Alangkay.
Okay. So this is the flow chart showing the process that will occur in the system. So as the pedestrian will push the button, video sampling will occur. The image capturing unit will now take a video of the scenario or the environment of that road. And image processing will take place and will now obtain the data. This data will now include the pedestrian density and the vehicular flow in that road. Now, this data will now go to the control unit. In the control unit, there will be a process called declassification, meaning this data will now be evaluated here. Now, as data will be evaluated, and we'll try to answer the question: Are the conditions, or the data, viable for pedestrian green light? So this, in the control unit, we will have a set of logic rules. So this one rule could be if the pedestrian density or the vehicular flow is slow, then the waiting time for the pedestrian will also be low. So that's one rule in the logic, in the control unit. So the set of rules is already tabulated in the paper. So again, in the diversification will answer the question: are the conditions viable for pedestrian green light? If yes, then it will turn on the green light for the pedestrians. And then if no, it will increase the waiting time for the pedestrians. Then eventually turning on the green light for the pedestrians. Now, this system could be evaluated using software simulators such as HotSim or NetLogo or other software simulators. So that's it. So for the conclusion will be presented by Mr. Haraminga.
Thank you. So for the, in conclusion, using this system can be more efficient. Comparing it to the current pedestrian and traffic signals here in Baguio. Because according to Xiao and his colleagues, it is feasible and it can control the signal status of the pedestrian. From Mitmaki and Kikuchi as well, that the use of fuzzy logic control system can be better than a actuated demand control system. It can also imitate an traffic enforcer. So for the recommendation, Ms. Kambi.
Given the information above, this paper only suggests to design a system for a pedestrian crossing signal with the existing researchers. For example, from the study of Vasconcillo and his co-authors, they found out that the fuzzy logic system will result the low rate of car congestions, lessening the waiting time at a traffic intersection. So it is recommended that this system would be simulated over a super simulator, then simulated at the real world. That's all. Thank you.